Welcome to Ask and Learn.
So for problem 15.189, we'll be given the constant angular velocity of the disk of the portable sonder. This is 4,400 RPM. This is rotations per minute. And we've been asked to find the angular velocity given that a worker rotates the sonder about the z-axis with an angular velocity, let's call it omega 2 of 0.5 radians per second, and with an angular acceleration, let's call it alpha 2 of 2.5 radians per second, which are both clockwise from the point of view of the positive z-axis. Before we go on with the solution, let's write down some things a bit more clearly. So we need to convert RPM to radians per second. The way we do this is just multiplying by 2 pi and dividing by 60. This is because one rotation equals to 2 pi angle, and we have to divide by 60 in order to get per second, in order to convert per second. And this gives approximately 767 radians per second. And also, given the information about the direction of omega 2, let's write it in a vector form. Omega 2 equals minus 0.5 k hat. This is radians per second, and alpha 2 equals minus 2.5 radians per second, and this again with a k hat. Okay. For this kind of problems now, it's better to use a rotating frame of our choice instead of the fixed given frame. It makes our lives more easier. So, and this is in order to use this formula. So the acceleration is the rate of frame, is the rate of change, of the angular velocity. This is with respect to the fixed frame, and we can express this from the point of view of a rotating frame in this form. I use prime for the rotating frame. This is the angular velocity of the rotating frame with respect to the fixed frame, and this is the angular velocity of the object from the point of view of the rotating frame. Okay, now we have to choose now a rotating frame which is convenient for our case. If this is, let's say the fixed frame, the rotating frame of our choice will be one such that the z prime axis coincide with the z-axis of the fixed frame, but the y prime axis coincides with the direction of the omega 1 angular velocity of the disk of the sunder. Let's try like this, which is parallel to omega 1. And the x prime axis follows from this. So this implies now that the angular velocity of the rotating frame is just a omega 2. And from an observer now moving with the rotating frame, the observer only sees the motion of the disk of the sunder. So the angular velocity from the point of view of the rotating frame is just 1. And now the rate of change of the angular velocity from the rotating frame is again alpha 2, because the angular velocity of the disk of the sunder is constant. And even though we have a motion, the observer moves with the rotating frame, the rotating frame moves with supposedly with a constant angular velocity, but the rotation about the z-axis is accelerating. So the rotating observer, will indeed identify that there is an acceleration about the z-axis, an angular acceleration about the z-axis. So let's write this more clearly. So acceleration now is this one. Which is 2.5 k hat plus 0.5 k hat cross product, the value that we calculated before, and for which vector now we take it that it rotates, that it is parallel to the rotating y-axis. And this gives us that's finally we get an expression like this in radians per second per second.